So, gravity. What is it? Is there such a thing as anti-gravity? Well, my name is Eugene, and let's discuss gravity. So in my previous videos, I discussed the model of the universe that I'm basing um, all my beliefs about gravity. And also in my previous video, I went over particle interactions based on that model. So if you have not taken a look at that, please do so. So let's get started. Um, so what is gravity? So just to summarize quickly, so we have our universal bubble, okay? And then in our universal bubble we have a single particle, and this single particle has infinite velocity and essentially bounces around inside this universal bubble. And then in order to observe reality, or in order to create reality, we essentially have an instrument that is able to, let me do a different color. We have an instrument that is able to open, or how shall I say, it's able to vibrate or open and close, similar to how a strobe light works, where it flashes at certain frequencies. Now this instrument does the same thing, where it's able to, when it's on, it's able to observe the particle going through the instrument. So whenever it's open and the particle is present, it will record that particle. Or whenever the particle crosses the same location, there's a better chance that it will record that particle itself. So it has a really small frequency where it exposes, where the particle, where it gets that exposure of the particle. So in that respect, the reality frames are essentially built up of whenever it's vibrating at a certain frequency, it builds up a picture of that frame. So if we observe this particular, if we observe the reality bubble at a certain frequency, we start getting frames. Well, at a certain frequency we get one frame, and then at another frequency we get a different frame, and so on. So that is how reality is built up, where we have continuity by changing the frequency of this instrument, so that it has different reality frames, and that represent continuity. So for instance, if we have a falling ball, the ball would start over here, then the next frame would be there, and there, and there. So that essentially represents a continuity. So if we have this particle bouncing around, looks like my pen is drying up. So if we have this particle bouncing around in this universal bubble, then essentially whenever it crosses, we can observe the particle. So that means the entire bubble is virtually filled with particles. So that means that our entire universe is filled with particles. So in the previous video, we discussed how particles behave and what causes them to behave in such a way. We discussed that if you had two particles or two similar particles, they tend to attract to each other, and if they are clumped together, they want to repel each other. They want to move away from each other. And one of the reasons these particles exhibit those behaviors is because, especially if you're in a, let's say you have a bucket of water or a container of water, and you create a vacuum, within that container, suddenly create a vacuum, then as soon as the vacuum forms, you'll have an implosion of water to fill that vacuum. So everything rushed towards the center. So this is essentially, what's happening when we have the universal bubble, filled with all these particles. Whenever you have matter within this universal bubble, it creates areas where you have an absence of these particles, so which is similar to creating a vacuum. And as such, these particles wants to fill that vacuum, and it will therefore exhibit a pressure onto any matter within that area. So that is essentially what gravity is. It's essentially certain particles that wants to fill a void, and it sees the matter as a void, and it wants to try and fill the void. So it's a little bigger. So if you have a planetary body, right, and you have our universal bubble filled with all these particles, this planetary body represents a void. So in other words, all these particles, they will move towards the center of this, and the reason why they move towards the center is because of the pressure of the surrounding particles. All the outside particles trying to push towards the inside to fill the void. So what's happening is you'll have a flow, inward flow of these particles, and let's say we call these gravity particles, because astronomers have observed the known universe, right, in their telescopes, and they have observed that gravity seems to be everywhere, just by looking at the behaviors of solar systems and galaxies. So I can make the deduction, based on my model of the universe, that most of these particles are gravity-like particles, or gravitons. Let's call them gravitons. Gravitons, the entire universe essentially filled with these. So they appear to be the building block, or not the building blocks, but the glue that holds everything together. And the main reason that they behave that way is just because there's a lot of them, and they don't like voids. And matter represent a void to them. So in other words, whenever you have something like a planetary body, you'll have enormous amount of pressure of these particles trying to fill the void. So then what happens is, right at the boundary of this planetary object, you'll get a bigger pressure. As the particles move towards, get pushed towards this planetary body, it experiences a barrier essentially, as it tries to penetrate this planetary body. Now these gravitons are small. It can, it filters through any matter. It's there's no chemical reaction. So if you have, let's say this is what your matter is, just a bunch of atoms, molecules, whatever. And if you have these gravity particles coming down, moving through it, so what happens is they encounter resistance as they filter through this. So initially, as a whole bunch of them start to crowd, right, as they're trying to filter through the matter, so we'll get a whole bunch of particles right there, and then we'll get less and less going through the matter. So if you have like an object over here, if you have an object over here and you have the planetary body over here, then if this object is in the path of this gravity flow, then what happens is this object gets dragged along, towards the center of the planetary body. So typically, right, it will just stop on the surface. Right? So if you throw something up in the air, you're actually throwing up against a downward draft, or like a waterfall of gravitons. They're coming down, they hit the object, filter through it, drag it down. So if we look at our planetary body again, we have, we essentially have compressed area gravitons, just because there's a boundary, and they filter all in towards the center of the planetary body, or the center of the mass. So what's happening then, if they filter into this area or the center, they have to go somewhere, right? So there's a build-up of these particles, right? And they're building up because when they hit in the center, they'll experience crowding, right? So when particles experience crowding, they want to push away from each other, right? But they cannot push away because we still have an incoming flow of particles, and the external pressure is also pushing, towards the center. So anything that wants to try and escape will be met by other incoming particles, and they would be bounced back. So what's happening then is we'll have pressure building up, and these particles want to escape the crowding, and eventually you'll get a big explosion where these particles will explode out at high velocity. So when these particles come in, right, it's a relatively slow process where they filter down. If you drop an object, right, and gravity gets hold of it, the contents inside the object, becomes weightless, right? We have those planes where they go up and they drop, and then they can, play around with artificial gravity, or with microgravity, that's what they call it. So that's the same effect where this plane goes up and it then falls with gravity. So when they experience weightlessness, it's because the gravity particles that they are moving at the same speed the gravity particles coming down. So that is the reason they then experience weightlessness when they do that. Anyway, so when pressure builds up, you'll have a big explosion of these particles, right? So now that creates a void. So now we have almost like a pulsing or jerking effect, where these particles, pressure builds up, big explosion, and suddenly you have a fast movement towards the center. So this cycle continues, so there is a frequency to it. So this So you have a cycle of building up and a cycle of releasing. So gravity, Earth gravity does have a certain frequency. So does the sun. The sun have a different frequency. And any other planetary body, every planetary body or any universal body essentially have a frequency based on the drama that ensues because of this flow. Okay, so like I said, right, the incoming gravitons, they slowly filter, relatively slowly, filter through the object, but when it explodes really violently. So, so when it when it explodes through the planetary body, it essentially pushes anything that's in its way, any molecules, any atoms, pushes out of the way, and essentially just rips right through it. Okay. So this object never experienced any effects from this because the particles travel so fast that they don't experience any effects. Also, as this particle explode outwards, it encounters these incoming particles. So essentially, these particles, it causes them to slow down because now they are interacting and bouncing or colliding with the other particles. So you'll get a slowdown of these particles until they stop, and then eventually the cycle continues. Right. So you'll have incoming, explode, fast out, slow down, and back into the center. Okay. And then, any objects that are caught in this, in this drama will get dragged towards this planetary body. Now, the effect of this gravity is far-reaching, right? We can see it in our solar system where the planets generally keep their distance. So there is an effect, and we'll get into that in a second as to why planets stay from each other. Also, when we send out satellites or astronauts to orbit the Earth, right? So when they go up in their rocket at a certain 100 miles, that's the edge of space, they start experiencing weightlessness, right? So what's happening there is so the inflow of gravity particles, gravity particles are still coming in from quite a distance, right? So they are experiencing some gravitational pull towards the center, but this outburst of particles, right? When they reach this position, they have slowed down enough to start affecting the body or start affecting anything close to the planet. So in that respect, the objects or the astronauts, they'll start getting that weightless feeling because the incoming gravity particles, right, matches there's a balance between the incoming and outgoing. So they are not pushed away or pulled towards Earth. They are more or less weightless. Now, if they go further away, obviously, the effects will be less, and they'll experience true weightlessness, and they only experience weightlessness because there's no gravitational path right towards, or the gravitational pull is not strong enough. But there's always gravity particles in space. It's just that there's no direction or no current for them to follow. So that's essentially, based on my model, how I see gravity works. And based on this, we can start formulating how we can build a device to shield us from gravity. So what is the anti-gravity aspect then? So the anti-gravity aspect then, I guess there's essentially no anti-gravity. It's all gravity. It's it's all the same thing. It's just the particles moving in different directions. So I suppose the anti-gravity part would then be just having the ability. So when you're at the surface or close to the surface of a planetary body, right, you have an updraft of gravity particles, and then have the ability, let's say, as your craft or your device, and have the ability to form a barrier, right, that prevents these particles from moving through the barrier, and therefore your craft then would float on this updraft. So imagine like these, like streams of water shooting up, right, and then trying to balance on that or float on top of that streams. Okay, so let's take a look at, do I need that? Let's take a look at planetary bodies. Okay, so if you have two planetary bodies, right? So what's the reason? Since gravity attracts everything, right? If we have a gravity field over here, right? Everything caught in the field will get attracted towards the planetary body, right? So if you have two planetary bodies, what's the reason that they don't collide, or they're relatively same or equal size? So the forces that they exhibit should be similar. So what is the reason then that they do not collide? Well, we've in the previous video we discussed, when you have two magnets and you have opposite poles, and you have the same poles, right? So if you have two south poles, should I forget again which way is the outlet? But you have two outlets, right? So obviously, if you have two hoses shooting at each other, they're gonna push off. They will keep away from each other because of the outflow of the water, right? Now, if you have two inflows, and the reason why they don't meet up with each other is because you have this inflow of particles trying to enter the inlets. So the forces, so it's because of the inflow of particles that keeps them away. So we have the same scenario here, where you have the influx, right? We have the influx of gravity particles, right? So if we have gravity particles all over, there's the bubble, right? And they're trying to fill the void, right? So they are moving towards the gravity center. So it's because of this influx then of particles that prevents these two masses from hitting each other. Another aspect also, right, is the outflow of particles, right? that also plays a role. Now, if these somehow get really close, right, that's when these outflow particles kick in, because these guys they um, they have an effect at a shorter range, right? I explained before that when they explode out, they meet the incoming particles and then they get slowed down. So their effect is not, it doesn't have a long range. So the planets will have to be really close to each other to experience that push away. Okay. So how do we shield in gravity, right? So first of all, if we have the planetary body, right, and we have the incoming particles, gravity particles, right? So if we build our device, let's make it blue. Okay, so if we have our craft, let's say our craft, right? Okay, so if we don't have any protection from gravity, then what's happening is the gravity particles will filter through this craft, right? And it will drag everything its way. The occupants will experience the effects of gravity, and will have to have some sort of lifting mechanism like thrusters. To push off the or to stay aloft, right? So in order to have a device or craft that's not affected by gravity, right, we would have to have some sort of mechanism that builds a barrier. It needs to build a barrier around this craft that when the gravity particles come in, they are unable to penetrate the barrier. They essentially get bounced off. Right. So, as I've explained before, right, when these gravity particles, right, they get reflected and deflected and bounce off other gravity particles. Also, when you have this updraft, these updraft would also be affected by, and depending on the height of this craft, right, it could either still shoot through the craft or could be significantly slowed down as it shoot through the craft, but it will also be deflected in some ways by this barrier, right? And as I've explained before, when you have this updraft and it hits all these particles coming down, it gets slowed down because it is affected by the gravity particles. So, given that behavior, our barrier would then have to be made of the same gravity particles. Right? It's similar to how you can block water with water. You can block the flow of air with air. So if you have two hoses, right, one hose block the other hose and the water won't come through. You can also block air with with another column of air. So in a similar manner, right, if we build a barrier of gravity particles, then the natural occurring gravity particles within this universal bubble would not be able to penetrate this bubble, and then the occupants would not experience any effects of gravity. So let me just go over the effects of gravity I'm talking about here. So when you are in the universal bubble, right, you are surrounded by these gravity particles, and you have an object, right, and you have these gravity particles trying to fulfill that void, or trying to fill the void. So you have these particles in here too. So now if you somehow, let's say it's a rocket, right? No, let's say it's a rocket. Okay. Right. And it's moving through space. So now what's happening is, as they encounter these gravity particles, and these gravity particles most likely don't have any net direction. They're essentially neutral. So this craft will then encounter these gravity particles, and then these gravity particles will start exhibiting a drag on this craft, right? So the faster this craft goes, the more drag it gets, or the more heavier it will appear, because as been postulated by Einstein, right? Nothing can go faster than the speed of light, because the craft gets so heavy and that it cannot accelerate any further. So this is exactly what's happening, is because it's absorbing all these gravity particles, and it therefore has drag. Similarly, right, if this craft is moving and wants to change direction, it becomes difficult to move direction, because now it is caught, because these gravity particles, they it's a tight cluster of these gravity particles, right? So now this craft is filled with these gravity particles. So if this craft wants to change direction, they cannot immediately change direction. They have to slowly change direction. That is because these gravity particles are holding on to this craft, and it is now locked into the framework, right? Because as they move, right, this craft is also dragging with the gravity particles. So it's accumulating some, and it's also causing a stream of these gravity particles to flow with it, right? So if it wants to change direction, it cannot immediately change direction, because it has to count for these gravity particles. The gravity particles want to go, keep going straight, right? So essentially there's inertia. So you'd want to keep going straight, and so any matter that wants to change direction, right, will encounter this flow of gravity particles going this direction. So it will become difficult to change direction. Similarly, if this craft suddenly stops or hit a barrier, right? What usually happens then is, or it somehow suddenly stops, right? Maybe it's not a barrier, right? It has thrusters on this side, which slows it down, so the occupants experience, deceleration. And the reason for that is, right, since this craft is filled with the inside of the craft and the entire craft, and its occupants are filled with these gravity particles because they have absorbed it, as they move through space. When the craft suddenly slows down, right, these particles, the gravity particles, this essentially gravity particle flow, right, they still continue in forward motion. So the occupants would then also be dragged along, and get smashed into the wall or something. So that's how gravity affects things. It results in the behavior that we see on Earth today, where right? Particles experience, inertia, right? Our crafts cannot suddenly stop. They have to, come to a slow stop. They cannot just suddenly turn 9 degrees. Um, so if we are able to then shield the occupants of this craft from gravity, and if this craft moves in the same way I just described, then it would not experience the same effects. Number one is the craft would have unlimited speed, or would travel really fast, right? Even faster than the speed of light, because as it travels, and as it has the gravity barrier, the gravity particles cannot penetrate the craft, so it doesn't have any inertial effects on this craft. So this craft would be able to travel very fast. It will also be able to make 9 degrees turns, because this craft is not affected by the external gravity particle field. So the craft itself would not experience the inertial effects. Or the craft can stop instantly, without affecting the occupants. So what else? So another aspect is the shape of the craft also matter. If you just have the craft as a circular body, right? A circular craft or sphere, definitely it's a good shape to be protected from the downdraft. But when you have an updraft, right? How do you control such a shape? How do you make a sphere, float on, an upstream of particles, and how do you have it stable, right? So the best shape for that is to flatten it. Actually, to have like a V shape at the bottom, right? So that way, this is a more stable shape, right? So we have like the classic saucer shape. That is a more stable shape to float on something and to balance on something. So, and also it's round, of course. So looking from the top down, it's round. All right. In my next video, we'll discuss the mechanism of how we build that barrier around the craft, and also maybe go through some experiments to prove this concept. I'll see you next time. Thanks.